Hello students. Last class we have discussed about the introduction part of acid, base and buffer solutions. In this part we have discussed buffer solutions and buffer actions. What do you mean by buffer solution? The buffer solution, the solution that are able to resist the change in pH values known as buffer solution. Change in pH values known as buffer solution. It consists of mixture of weak acid and its salt, or mixture of a weak base and its salt. The solution that are able to resist the change in pH values known as buffer solution. Mainly three type of buffer solution is there. First one, acidic buffer solution. Second one, basic buffer solution, and third one, neutral buffer solution. First one, acidic buffer solution. What do you mean by acidic buffer solution? An acidic buffer is a combination of weak acid and its salt. Weak acid and its salt. Examples: acetic acid and sodium acetate, carbonic acid and sodium bicarbonate, phosphoric acid and sodium phosphate, formic acid and sodium formate. These are the examples of acidic buffer solutions. Next, basic buffer solution. A basic buffer is a combination of a weak base and its salt. It's a combination of weak base and its salt. It's known as basic buffer solution. It's a mixture of weak base and its salt. Examples: ammonium hydroxide and ammonium chloride, ammonium hydroxide and ammonium chloride, ammonia and ammonium chloride, ammonia and ammonium carbonate. These are the examples of basic buffer solution. Next, neutral buffer solution. It's a mixture of weak acid and weak base. It's a mixture of weak acid and weak base. That's known as neutral buffer solution. Neutral buffer solution is a mixture of weak acid and weak base. Examples: acetic acid and ammonium hydroxide. Acetic acid and ammonium hydroxide. Acetic acid is a weak acid. Ammonium hydroxide is a weak base. Next, properties of a buffer solution. These are the main properties of buffer solution. The pH of buffer solution remains constant. pH of buffer solution remains constant. Second point, the pH of solution does not change on dilution. The pH of solution does not change on dilution. Third point, the pH does not change even after addition of a small quantity of acid or base. The pH does not change. pH does not change even after addition of small quantity of acid or base. Fourth point, the pH of a buffer solution does not change on keeping for a long time. The pH of buffer solution does not change on keeping for a long time. Fifth point, the pH of solution remaining constant is useful in number of chemical reaction. The pH of solution remaining constant is useful in number of a chemical reaction. Next topic, buffer action. The buffer action is the resistance of a buffer solution to a change in pH known as a buffer action. The resistance of a buffer solution to a change in pH is known as buffer actions. Next, mechanism of action of acidic buffers. Mechanism of action of acidic buffers. Consider a buffer system of a acetic acid. Acetic acid is a weak acid or weak electrolyte, and sodium acetate is a strong electrolyte or salt. It's salt. Salt of acetic acid. Consider a buffer system, acetic acid and a sodium acetate buffer system. There will be a large concentration. There will be a large concentration of Na plus ions and acetate ions, CH3CO minus ions, Na plus CH3CO minus ions, An undissociated acetic acid molecule is also there. CH3COH, undissociated acetic acid molecule is there. Na plus ion is there. Sodium acetate ion is there. CH3CO minus ion. CH3CO minus. CH3CO minus ion is there. Next, when acid is added in this buffer solution, that is acetic acid, sodium acetate buffer, when strong acid is added, example HCl is added in sodium acetic acid sodium acetate buffer system, the changes will be represented as the changes will be occurs. The reaction is the first, they consist of CH3CONA, sodium acetate ion is sodium acetate ion dissociated from Na plus and CH3CO minus ions, Na plus and CH3CO minus ion. And strong acid is added. When HCl is added, they dissociate from H plus and Cl minus ions. In this action of this, the hydrogen ion yielded by HCl hydrogen ion yielded by HCl are quickly removed as unionized acetic acid. They quickly removed as unionized acetic acid, and hydrogen ion concentration is therefore only slightly affected. The hydrogen ion concentration is therefore only slightly affected because acetic acid is produced very weak as compared to HCl. Because acetic acid is produced is very weak as compared to HCl. Understand? Reaction. A small quantity of H plus is HCl is added. As acid is added, the H plus ion concentration is decreased by the H plus ion concentration, hydrogen ion concentration is decreased by they reacted with the acetate ion CH3CO minus CH3CO minus ion to will form acetic acid. Acetic acid is undissociated form. Acetic acid is formed. Therefore, decrease the H plus ion concentration. Next, when base is added in this buffer solution, acetic acid sodium acetate buffer solution, when strong base is added, NaOH, the changes will be represented as is the reaction. Acetic acid is dissociated from sodium acetate molecule, acetate ion and H plus ion. When base is added, when a strong base is added, they dissociate from Na plus and OH minus ion. This increase the concentration of OH minus this OH minus ion concentration is decreased by they react with H plus ion. H plus ion, they react with H plus ion, it form water, H2O. Water, H2O. The hydroxyl ion yielded by the NaOH are therefore removed as water. The hydroxyl ion yielded by the NaOH are removed as water. The supply of hydrogen ion is needed for this purpose being constantly provided. The hydroxyl ion yielded by the NaOH are therefore removed as water. The supply of hydrogen ion is needed for this purpose being constantly provided by the dissociation of acetic acid. The supply of hydrogen is needed. They are constantly provided by dissociation of acetic acid. Next, mechanism of action of basic buffer solution. Consider a buffer system, ammonium hydroxide, ammonium chloride buffer system. The ammonium hydroxide is a weak base, ammonium chloride is a weak salt or strong electrolyte. Their salt. Mechanism of action of basic buffer solution. Consider a buffer system, ammonium hydroxide and ammonium chloride. The ammonium hydroxide acts as a weak base. Ammonium hydroxide acts as weak base. Ammonium chloride, salt of this weak base. They act as a strong electrolyte. There will be a large concentration of ammonium ion and chloride ion and undissociated ammonium hydroxide molecule is there. There will be a large concentration of ammonium NH4 plus ions, Cl minus ion and undissociated ammonium hydroxide molecule. Next, the reaction. When an acid is added, If a strong acid HCl added in ammonium hydroxide ammonium chloride buffer solution, the changes will be occur represented as this is the changes reaction is represented as ammonium hydroxide. They dissociate from ammonium ion NH4 plus OH minus ion. When small quantity of acid HCl is strong acid is added, they dissociate from H plus and Cl minus ion. This H plus ion concentration is decreased by they react with this OH minus ion. It will form water H2O. Understand? These are reactions of when acid is added. When a strong acid is added to ammonium hydroxide ammonium chloride buffer solution, the changes that will occur may be represented as. Next, the hydrogen in this reaction, the last reaction, when acid is added in this buffer system ammonium hydroxide ammonium chloride buffer solution, the hydrogen ion yielded by the HCl are therefore removed as water. The hydrogen ion yielded by the HCl are therefore removed as water. The supply of OH ions is needed for this constantly provided by the ammonium hydroxide. The supply of OH minus ion is needed for the is constantly provided by ammonium hydroxide. Next, when base is added, when a strong base NaOH is added in the buffer solution ammonium hydroxide ammonium chloride buffer system, the changes will be represented as. When a strong base is added, increase the concentration of OH minus ion. It will be decreased by ammonium chloride. They dissociate from Cl minus and NH4 plus ion. This NH4 plus ion and OH minus ion will be react. They form ammonium hydroxide NH4 OH undissociated ammonium hydroxide ion. These are the reaction. The hydroxyl ion yielded by the NaOH are therefore quickly removed and ionized ammonium hydroxide, and the pH of solution is only slightly affected. Next, mechanism of action of phosphate buffer solutions. Phosphate buffer system. Consider a buffer system: potassium dihydrogen phosphate and potassium monohydrogen phosphate buffer system. They consist of two ions H2PO4 minus ion. This is a dihydrogen phosphate ion H2PO4 minus ion serve as a weak acid, and HPO4 2 minus serve as conjugated base. HPO4 serve as conjugated base. When a hydronium ion are added, in a hydronium ion, these are the H3O plus. This hydronium ion is added. HPO4 is a mono HPO4 2 minus to form dihydrogen phosphate ion H2PO4 minus plus water. Understand? HPO4 2 minus they react with the hydronium ion to will form H2PO4 minus plus water. When a hydroxyl ion added to these buffers, the following reaction takes place. The hydroxyl ion OH minus ion is added. Dihydrogen phosphate ion, their OH minus react with the dihydrogen phosphate ion. It will form HPO4 2 minus monohydrogen phosphate ion HPO4 2 minus plus water. These are the mechanism of action of phosphate buffer solution. Mechanism of action of phosphate buffer solution. These are the topic covered by buffer solution and buffer action. Okay, thank you all.